T-minus 10, 9, 8,
The clock is
7.
operating. We're underway.
Tranquility Base here.
Endeavor, go at throttle up.
The message for 20 millimeters.
Meanwhile, preparations also continuing at the Tanegashima Space Center in southern Japan for a launch of the HTV-2 or Kanatori-2 spacecraft that'll be delivering about 4.2 tons of cargo to the International Space Station. We can see rollout of the H-2B launch vehicle and the enclosed Kanatori-2 spacecraft beginning now in Tanegashima, Japan. Launch for that vehicle is scheduled tonight at 11:37 p.m. Central Time, which is about 2:37 in the afternoon in Japan. The launch was delayed by a couple of days when clouds and potentially freezing precipitation in the area of the launch pad made it for unfavorable conditions. Right now, the weather conditions are expected to be fair at launch time, although they're supposed to be a little bit cloudy right now. The average wind speed for today is expected to be about 15 to 22 miles an hour. And the team at the Tanegashima Launch Center is expecting good weather for tonight's launch. As we continue to watch these rollout pictures of the H-2B launch vehicle in Tanegashima, Japan, with its Kanatori-2 or HTV-2 spacecraft mounted atop. This is the first of a quick succession of international space supply trucks that are scheduled to arrive on the International Space Station's loading docks during the early portion of this year. They're going to, all in total, drop off about 11 tons worth of food, computers, medical equipment and supplies, spare parts, and experiment gear for the station. Not to mention the everyday necessities of life on orbit. Kanatori-2, which means white stork in Japanese, is developed by the Japan Aerospace Exploration Agency. This is the second flight of the system to the International Space Station. On its heels will be the 41st Russian Progress vehicle, which is set to launch from the Baikonur Cosmodrome in Kazakhstan on January 28th, and the second European Space Agency automated transfer vehicle, known as Johannes Kepler, set to launch from a pad in Kourou, French Guiana on February 15th. HTV-2 is a 33-foot long, 13-foot diameter spacecraft. Allows for unmanned cargo transfers, both internal and external supplies for the station. All told, it has about 4.2 tons of cargo on board. And when it approaches the station on January 27, assuming launch tonight as scheduled, astronauts Katie Coleman, Scott Kelly, and Paulo Nespoli will use the space station's robotic arm to reach out and grapple and berth it to the Earth-facing port of the Harmony module on the station. Altogether, the HTV-2 vehicle and cargo weigh about 35,408 pounds, or more than 16,000 kilograms. Total amount of external unpressurized cargo that's being delivered is 2,043 pounds, or 927 kilograms. Of that, about 1,990 pounds, or 900 kilograms of the external cargo is NASA cargo, and about 53 pounds, or 24 kilograms, is Canadian Space Agency cargo. Inside the Kanatori 2's pressurized environment will be about 6,455 pounds of cargo. That's 2,928 kilograms. 2,800 pounds of that is NASA cargo, and 3,600 pounds of it is JAXA cargo. And it breaks down to 1,389 pounds of crew provisions, 3,585 pounds of research equipment and supplies, 1,343 pounds of space station hardware, 108 pounds of computers and computer supplies, and 31 pounds of spacewalking equipment and supplies. We will have live coverage of the Kanatori 2 launch from Tanegashima in southern Japan tonight, with coverage scheduled to begin at 11 p.m. Central Time. This is Mission Control Houston as we continue to watch these rollout pictures of the Kanatori 2 spacecraft on its H-2B launch vehicle at the Tanegashima Space Center in Japan. The latest word from the Environmental Systems Officer here in Mission Control about the upcoming Russian EVA-27 is that the pressure is stable inside the Pirs airlock, and there are no impediments right now to hatch opening. But we'll continue to watch this rollout as H-2B rocket and its payload arrive at the launch pad in Tanegashima. The launch pad clearly defined there by the two lightning protection towers on either side of the launch pad. Getting some great close-ups of the workers that are following the mobile launch platform for the vehicle.
For EV1 and EV2. Demating electrical umbilicals. Copy. EV2's umbilical is demated. Copy, Oleg. EV1 has the umbilical demated. Copy. Close the suit's electrical connector with MLI. Proceeding. Closed on EV1s, and then EV2s also closed. Copy, Oleg.
This is Mission Control Houston. We are continuing to watch the arrival of Kanatori 2 and the H-2B launch vehicle at the Tanegashima Space Center launch pad, but we have gone ahead and provided the audio now to NASA television for the final preparations for the hatch opening for Russian EVA number 27 aboard the International Space Station for Dmitry Kondratyev and Oleg Skropochka. They're in the process of removing their umbilical connections to their spacesuits to become spacecraft in their own right as they get ready to exit the hatch.
EV1 demated. Copy. Dmitry, you should have on your display CO2, PO2 primary, and U battery. PO2 primary is 400, battery is 28. What about you, Dmitry? 30.5 for U battery, and PO2 is 404. Transition BSS to O2 closed. Okay, installing caps right now on the fluid umbilicals. As soon as I'm done with that. O2 is closed on BSS. You can proceed with O2 closed. Copy. The pressure is 039. Copy. Okay, guys. You will proceed with the hatch opening activities and subsequent, and we will talk to you In repress, you're doing well. I'm handing you over to Sergey. Thank you. Good luck.
Я измерил нормально.
Oleg, Dmitry. Hi, Sergey. Hi. What's the pressure in the compartment? Right.
In Mission Control Moscow, the voice loop's being handed over to Sergei Osipov, who will be guiding the crew members through their spacewalk as they get ready to open the hatches and steps outside of the Pirs docking compartment. We are continuing to watch the arrival of H-2B and the HTV-2 or Kanatori 2 White Stork spacecraft at the Tanegashima Space Center in Japan.
You can proceed.
All systems also checking out properly, and the crew has been given the go to prepare to open the hatch on the Pirs airlock and begin their spacewalk.
And Oleg, I will read the stuff up to you. Right now, I seem to be doing all right. You have to make sure that the emergency closure
This is Mission Control Houston, and welcome to NASA Television's live coverage of the launch of the Japan Aerospace Exploration Agency's cargo craft, HTV. This is a live shot from the Tanegashima Space Center there in the southern part of Japan. The rocket is currently fully fueled and awaiting its launch coming up tonight at 11:37 p.m. Central Time. That will be 2:37 p.m. local time there in Japan. All of the teams there in Japan and also here in Houston have been monitoring the progress of this evening's countdown. Jerry Jason is the current flight director who is on console. He is actually in the middle of handover operations with his oncoming flight director, which will be Brian Smith. But here just a few minutes ago, Jerry Jason and his entire team here in Houston notified the team there in Tsukuba, Japan, that all the operators here in Houston were go for launch. The International Space Station is in the proper configuration for the launch, so everything is on track for this evening. The weather there in Japan, which had caused a slight delay in the launch, it was supposed to take place on Wednesday evening, is as good as can be expected. There is no precipitation in the area. The temperature is 11 degrees centigrade, which is about 52 degrees Fahrenheit. So all things continuing to count down, the launch due to take place some 36 minutes from now. In preparation for tonight's launch, the HTV atop its H-2B rocket was rolled out of the vehicle assembly building there at the Tanegashima Center. That rollout occurred at 8 a.m. Central Time this morning at about 11 p.m. there in Japan. The rocket and the spacecraft had been prepared inside the vehicle assembly building. It's about 400 meters from that building to the actual launch pad itself, which is launch pad number 2. The rollout trip took about 30 minutes. The rocket is moved atop a movable launcher, much like the space shuttle is. This movable launcher also serves as the actual launch pad itself. There are 2 special transporters nicknamed Dolly that actually move the entire pad out of the vehicle assembly building. Each dolly has 56 tires, and the unique thing is that the dollies can move forward and backward and even sideways, and they can actually turn 180 degrees, each one of them. Back now with a live view, as we mentioned, This HTV is going to be lifting off from the Tanegashima Space Center in southern Japan. This particular space center was created in 1969 when the original National Space Development Agency of Japan was formed. There are 2 different launch pads in this part of the complex. Launch pad number 2 is used for the heavier vehicles. This is also the same launch pad that the original HTV lifted off from back in 2009, which of course was the maiden voyage of that cargo craft. The HTV cargo craft itself is 32 feet long by 14 feet wide. Whenever it has no cargo inside of it, it weighs more than 10 tons just by itself, but it can carry 6 tons of cargo to the International Space Station. This particular mission is carrying quite a bit more cargo than the first mission did. There's 5.3 tons of cargo on board. 51% of that spare parts, 24% is food, 10% of that is science experiments, 8% crew supplies, and 7% is water. As you can see from this diagram, there are several different sections to the HTV. On the far right-hand corner of your screen is the propulsion module. It's about 6.5 feet long and carries all of the fuel for the HTV itself. There are 4 propellant tanks that carry 2 tons of fuel on each flight. There are 4 main thrusters, which you can see there at the bottom, located at the very end of HTV. And there are 16 reaction control system thrusters, and another 12 thrusters are located at the top. Next up is the avionics module. This carries all of the onboard guidance, navigation, and control systems, as well as the communications, data handling, and electrical power systems. All of these systems combined help the HTV fly on its own during the more than week trip up to the International Space Station. The next section is the first section that carries cargo inside of it. This is the unpressurized logistics carrier. It measures 11.5 feet long and has a wide opening that accommodates the exposed pallet. This pallet is the large tray that carries on it several different spare parts for the station that will be stored on the outside of the orbiting complex. The interesting thing about HTV is it is the only other cargo craft other than the space shuttle that can actually carry unpressurized cargo inside of it. That exposed pallet will be the focus of activities coming up soon after the HTV is berthed with the International Space Station. That exposed pallet will be withdrawn using the station's giant robotic arm. It'll be handed over to the Japanese Kibo Laboratories robotic arm and will be mounted on the outside of the laboratory itself. As you can see here, this exposed pallet has several different items located on it. On this graphic on the left-hand side, you can see what is called the FRGF, and on the right-hand side, you can see the PVGF. These are both grapple points at which the station's robotic arm can latch onto, as well as the Japanese Kibo Laboratories robotic arm. There's also what is known as an HPIU. This is the HTV Payload Interface Unit, which will connect with the Kibo Laboratories exposed facility. This allows power and telemetry to be handed over from this exposed pallet to the Kibo Laboratory itself. One of the major items that this HTV is carrying up is the FHRC, which you see there, kind of the olive green colored doghouse looking item on the left-hand side. This is the flex hose rotary coupler. It is a piece of equipment that helps transfer and distribute ammonia across the station's thermal radiator rotary joints. These panels rotate around, and the ammonia in the coolant loops helps get rid of the excess heat that the station builds up. This will be the third spare FHRC that will be located on the outside of the station. The first one actually flew up on STS-114 back in 2005, and the second one was delivered in 2008 during STS-126. The other major spare part on this exposed pallet is a cargo transportation carrier, or CTC. You see it in the orange there on the left-hand side. This is basically a big box of spare parts like remote power controller modules and also some video distribution units. The first CTC was delivered on STS-129 back in 2009 and is currently stored on the outside of the station. The HBCS that you see there on the left-hand side is the camera system that will assist ground controllers and also the station's crew, as this exposed pallet will be put back into the HTV at the end of its useful life. That camera system will allow them to align this exposed pallet as it goes back inside the cargo container. The final section of the HTV is the pressurized logistics carrier. And this section is almost 11 feet long and carries all of the cargo that is used on board the station itself. This is the part that the crew will actually have access to. There is a hatch on one end of the HTV that the crew will be opening up and going inside HTV itself to get all of the different items that are carrying, that HTV is carrying up to the station. There are several different resupply racks that carry everything from food to water to experiment samples to clothes and other items that the crew will need. There are also 2 science racks on board, as well as an experiment in human research, some physics experiments, biology, biotechnology, and also some education samples. You can also see some of the solar panels in this diagram. HTV actually has 57 different solar panels that help power it during its flight. There are 20 panels located on the pressurized logistics portion. There are 23 panels on the unpressurized logistics carrier. There are 8 panels on the avionics module and 6 panels down there on the propulsion module. This once again a live view from the Tanegashima Space Center there in southern Japan. The HTV continues to count down toward its liftoff, coming up in a little less than 27 minutes. As we mentioned, the HTV is riding atop the H-2B rocket. It stands 186 feet tall. It is a 2-stage rocket that uses liquid oxygen and liquid hydrogen as propellants. There are 4 strap-on solid rocket boosters, which you see 3 of there at the bottom. There are also 2 liquid-fueled engines on the bottom of the first stage. Soon after liftoff, the rocket will conduct a pitch maneuver, much like the space shuttle does, to steer it toward the southeast, and it will head out over the Pacific Ocean. It'll take 1 week for HTV to get up to the International Space Station coming up on Thursday the 27th. That is when a series of activities will take place. The HTV will continue to close in on the International Space Station until it gets a few meters out. The Expedition 26 crew will be monitoring all of these activities. There are several different station keeping positions that HTV will stop and pause at for anywhere between 10 and 30 minutes. And once it is given the go-ahead, HTV will continue to close in on the International Space Station, placing it in range of the station's robotic arm. That will be used to grapple onto the cargo craft, turn it around. It'll then be steered around toward the bottom of the Harmony node, which you see there. There on the far right-hand side is pressurized mating adapter number 2. That is where the space shuttle docks with. HTV itself will go on the bottom side of Harmony. That is the Earth-facing portion of that module, known as the nadir side, and then it will be berthed. That is the exact same spot that the first HTV was berthed with. What is a little bit different about this flight is that HTV is going to be relocated to the top portion of the Harmony node coming up on February the 18th. That will clear the way for STS-133 and Space Shuttle Discovery to arrive during its flight.
Live footage from Tanegashima Launchpad number 2, where the HTV-2 Konotori 2 will be launched at 2:30 Japan Standard Time today.
This video coming to us from the Japan Aerospace Exploration Agency. That is a live view of the Scuba Control Center where they're monitoring the countdown. We're now 23 minutes and 43 seconds away from the liftoff of the HTV itself. You heard the JAXA commentator there talking. He mentioned the word Konotori. That is the call sign of this HTV. That is the Japanese word for white stork. So that is what you will hear them refer to that cargo craft as during tonight's flight. "23 minutes now until the launch of HTV.
From the HTV Mission Control Room, and you're listening to Tsukuba Space Center.
As we mentioned at the top of our broadcast, this team there that you see there in Tsukuba, Japan, is working very closely with the team here in Houston. The flight director there in Japan for this evening is Kota Tanabe. The person who is going to be serving as the JAXA lead attached phase flight director is Mr. Takashi Uchiyama. Also on console for the operations is Maki Maida. So that team there will continue to monitor tonight's countdown proceedings. We are 21 minutes and 39 seconds away from the launch of the HTV. Here in Houston, handover is continuing between the different orbit shifts. Jerry Jason, who has been the flight director for the last several hours, is currently handing over to Brian Smith, who will be the flight director. He is there on the right-hand side, Jerry Jason there on the left. You also see the model of the Japanese HTV there on the top of the flight director console. But a little more than 30 minutes ago, Jerry Jason and his team ran through their final go, no-go for tonight's launch. All systems were checked out here in Houston. They verified that the International Space Station is in the proper configuration for tonight's launch. So they officially gave the go to their counterparts in Japan right before we went on the air this evening. Once again, a live look at the HTV sitting on top of the H-2B rocket. As we mentioned, soon after liftoff, that rocket will be pitched over and head toward the southeast over the Pacific Ocean. You're getting a good shot of 3 of the 4 solid rocket boosters on the bottom of the H-2B rocket. Those will burn out at 1 minute and 57 seconds into the flight when the rocket is more than 30 miles high. About 10 seconds after that, at 2 minutes and 7 seconds into the flight, the first pair will be jettisoned. 3 seconds later, at 2 minutes and 10 seconds, the second pair will be jettisoned. At 3 minutes and 40 seconds into the flight, at an altitude of about 75 miles up, The fairing that is protecting and covering up the HTV, which you see a shot of there, will be jettisoned. At 5 minutes and 46 seconds, the first stage engine cutoff will occur, and 5 minutes and 54 seconds, the first and second stages will separate. At 6 minutes and 5 seconds into the flight, the second stage engine will be ignited, and that will burn for more than 8 minutes. At 14 minutes and 15 seconds into the flight, the second stage engine will be cut off, and then at 15 minutes and 5 seconds into the flight, HTV-2 will be separated from its rocket and will reach its orbital insertion.
Once again, this is live from Tsukuba Space Center. You're looking at a live footage from launch pad number 2 down in Tanegashima, where the weather's great, and we're about 15 minutes to launch time.
Once again, that's video and audio coming to us from JAXA. They're bringing us live coverage of the HTV rocket and H-2B rocket as it stands on the pad there at the Tanegashima Space Center. We're now 17 minutes and 49 seconds away from tonight's launch. As we mentioned, it will take about a week for the HTV to head toward the International Space Station. The actual grapple will occur at 5:44 a.m. Central Time on Thursday, January the 27th. We'll have live coverage beginning at 5 a.m. Central Time on that day. The actual berthing will take place at 8:15 a.m. Central Time, and that will go on for about 2 hours. And of course, we'll have live coverage of all that leading into that day's ISS update, which will occur at 10 a.m. Central Time. On February the 1st, the exposed pallet will be withdrawn from HTV itself using the station's robotic arm. Katie Coleman will be the prime crew member as part of Expedition 26 for all these operations. Paolo Nespoli, one of the other flight engineers, will be assisting her and will be serving as her backup. But the station's arm will be used to reach inside, grab onto that exposed pallet, which is carrying up 2 very large pieces of external cargo for the station. That tray will be withdrawn. It'll be very carefully steered away from the HTV itself and then turned back around up toward the Kibo laboratory. There is an external pallet on the outside of Kibo. It is called the exposed facility. It serves as sort of the front porch for Kibo. There's quite a bit of experiments and other items that are stored on the outside of that. That will be the temporary home for this exposed pallet. The crew will use the robotic arm that is on the end of the Kibo laboratory to grab on to this exposed pallet and take over from the station's robotic arm, and it will be swung around and plugged into that front porch of Kibo. From February the 2nd through the 4th, that is when all the different parts transfer will take place using the Canadian Dexter robot. Those spare parts are temporarily going to be stowed on Dexter itself until the arrival of ELC-4, which is an external stowage platform that will arrive on Space Shuttle Discovery. That exposed pallet that we showed you is going to be returned to HTV itself coming up on February the 7th. It'll be put back inside HTV, and that is where it will remain until the end of HTV's mission to the International Space Station.
最終カウントダウン進行判断の結果を連絡します。
We would like to inform you of a final go/no-go decision.
現在、各系ともロケット打ち上げの最終作業を実施中です。また、警戒区域の安全が確認されており、気象条件も打ち上げに支障のないことが確認されました。
All systems are now in final operations. All safety measures were confirmed in the restricted areas. Also, the weather conditions were examined and confirmed.
従いまして、H2B ロケット2号機の打ち上げを本日日本時間の午後2時37分57秒に実施します。
As a result, we are to launch the H2B launch vehicle number 2 at 2:37:57 p.m. Japan Standard Time.
この H2B ロケット2号機は国際宇宙ステーション補給機コウノトリ2号機 HTB2 の打ち上げを目的としています。
The objective of today's launch is to inject the HTV-2 or the Konotori-2, a cargo transporter to the International Space Station.
国際宇宙ステーション補給機は約1万7000通の公募の中からコウノトリという愛称が付けられました。
The nickname of the HTV, Konotori, meaning a white stork, was chosen from the HTV nickname contest among the 17,000 entries.
H2B ロケット2号機の打ち上げ時刻は本日日本時間の午後2時37分57秒です。
Today's H2B flight to liftoff time is at 2:37:57 p.m. Japan Standard Time.
This is Mission Control Houston. Back now with a live view inside the International Space Station Flight Control Room here at the Johnson Space Center. That is Jerry Jason coming into view, as well as Brian Smith there on the right-hand side. They have completed handover activities here in Houston, so Jerry Jason and his team are done for the evening. Brian Smith and his team will be on console for the next 8.5 hours or so. They will be watching over activities currently taking place in Japan as both teams here in Houston and in Japan get ready for the launch of the HTV. On board the space station, the Expedition 26 crew is currently in their sleep period. They had a very busy day today, as Dmitry Kondratiev and Oleg Skropochka, two members of Expedition 26, wrapped up a 5-hour, 23-minute spacewalk. They ventured outside the Russian segment of the station to install an antenna, as well as to retrieve some experiment samples and also install some other items on the outside of that part of the station. It was the 152nd spacewalk in support of space station assembly and maintenance. It brings the total hours of spacewalk spent on the station to 956 hours and 14 minutes. So the crew is getting some rest now, although Mission Control Houston is sending up our broadcast this evening so that the crew of Expedition 26 can follow along as this cargo craft heads toward them. Just a few minutes ago, you heard the team there in Japan giving confirmation that the final go has been given. All systems are continuing to count down to tonight's launch. Once again, it's going to take place at 11:37 p.m. Central Time. That will be 2:37 p.m. on Saturday there in Japan. We're now 10 minutes and 30 seconds away from the launch. The weather is clear. There is no precipitation anywhere near the launch complex. That had been a concern 2 nights ago, which was the original launch time for HTV. There was some weather in the area that delayed the launch by 48 hours. But all is looking good for today's launch. The temperature is about 52 degrees Fahrenheit. That is 11 degrees Celsius. And you see the beautiful ocean there in the background as the clock continues to count down. 10 minutes until the launch of HTV. All systems are go.
打ち上げ10分前になりました。種子島宇宙センター竹崎総合司令塔から H2B ロケット2号機の打ち上げ状況をお伝えしております。
It's 10 minutes to launch. This is a live report of the H2B launch vehicle number 2 launch from the Takesaki Range Control Center at the Tanegashima Space Center.
まもなく打ち上げられる機体は関係者による最終的な確認作業。現在のところすべて順調との報告を受けています。
According to the launch site operators, they are now conducting the final checks, which are all progressing well.
H2B ロケット2号機は午前5時00分からターミナルカウントダウン作業を開始。現在はその最終段階にあります。
The terminal countdown operations for the H2B Flight 2 started at 5 o'clock in the morning Japan Standard Time, and we are now in a very final stage.
打ち上げ8分前より打ち上げに向けた秒読みが開始されます。
The final terminal countdown will start at 8 minutes prior to launch.
打ち上げ8分前です。打ち上げに向けた秒読みが開始されました。
It's 8 minutes to launch. The final terminal countdown starts. 470.
種子島宇宙センター竹崎総合司令塔から H2B ロケット2号機の打ち上げ状況をお伝えしております。
This is a live report of the H2B launch vehicle number 2 launch from the Takesaki Range Control Center at the Tanegashima Space Center.
現在、各系ともロケット打ち上げの最終作業を行っています。また、経過区域の安全が確認されております。
All systems are now in final operations. All safety
This is Mission Control, Houston.
restricted areas.
The team here just having a quick conversation just a few minutes ago with Expedition 26 crew member Katie Coleman. They are watching our video here on NASA television as they continue to monitor the progress of tonight's launch. HTV is go for launch a little bit less than 7 minutes from now. That launch will take place at 11:37 p.m. Central Time.
The range safety system is...
The crew has had a very busy day. It was, as we mentioned, that spacewalk taking place earlier today. They are technically in their sleep period right now, but of course very interested in the launch that is about to take place in just a few minutes from Japan. Both Katie Coleman and Paulo Nespoli have trained extensively on HTV systems, as they will both be performing some of the robotic operations once HTV arrives in the vicinity of the International Space Station, and they use that station's arm to reach out and grab onto it and berth it with a Harmony node. It'll take about 7 days for HTV to head toward the International Space Station, and that will set off several days of extremely busy activities on board the station as the crew works to not only get HTV berthed with the station complex, but also that exposed pallet withdrawn and installed out there on the side of the Cubo laboratory, and all the different spare parts removed from that particular part of HTV. But they will also be opening up the hatches on Friday the 28th, and will undergo quite a bit of work to withdraw all of the different cargo that is inside the pressurized part of HTV and get all that tucked away and stored inside the station's different modules.
打ち上げ予定時刻は日本時間の午後2時37分57秒です。
Today's scheduled liftoff time is 2:37:57 p.m. Japan Standard Time.
310、309、308、307、306、305、304、303、302、301、300。
打ち上げ5分前です。
It's 5 minutes left off.
HTV2 準備完了。
The HTV, excuse me, HTV2 is ready.
88、87、86、85、84、83、82、81、280、79、78、77、76、75、74、73、71、270、69、68、67、66、
自動カウントダウンシーケンス開始。
64、
The automatic countdown sequence starts.
61、260、59、58、57、56、55、
種子島宇宙センター竹崎総合司令塔から 2B ロケット2号機の打ち上げ状況をお伝えしております。
This is a live report of the H2V launch vehicle number 2 launch from the Takesaki Range Control Center at the Takashima Space Center.
現在ロケットの管制は吉信発射管制塔から行われています。
The launch
The flight controllers there just outside of Tsukuba, Japan, continuing to monitor the progress of the countdown. We're now 3 minutes and 45 seconds away from the launch of the HTV. All systems are go. The team there has done their final polling to make sure that everything is set for this evening's launch. It is currently 2:34 p.m. on Saturday afternoon there in Japan. It is 11:34 p.m. Central Time, 12:34 a.m. Eastern Time. We're now about 3 minutes and 20 seconds away from the launch.
202、201、200、99、98、97、96、95、94、93、92、91、190、89、88、87、86、85、84、83、82、81、180、
打ち上げ3分前です。
It's 3 minutes still left off.
76、75、74、73、72、71、170、69、68、67、66、
全システムの電源が外部から内部に切り替えられました。
The launch vehicle is switched to internal power.
59、58、57、56、55、54、53、52、51、150、49、48、47、46、45、44、43、42、41、140、39、38、37、36、35、34、33、32、31、130、29、28、27、26、25、24、23、22。
This is Mission Control Houston, now 2 minutes until the launch of the Japanese cargo craft HTV. Once again, it is flying under the call sign of Konotori. That is the Japanese word for white stork. It was selected after more than 17,000 submissions were given to the Japanese Space Agency to name this cargo craft. It is set to lift off from the Tanegashima Space Center in 1 minute and 30 seconds. It is going to be heading up to the International Space Station for the next 7 days, carrying with it 5.3 tons of supplies for the Expedition 26 crew. This will be the second time that this particular spacecraft has flown. The first one, which was the original and maiden flight of HTV, took place back in September 2009. It spent more than a month and a half docked with the International Space Station. This particular HTV, number 2, will stay until about the end of March, docked with the International Space Station. After that point, it will be undocked and will head into a destructive re-entry into the Earth's atmosphere. Now 53 seconds away from the launch of the Japanese HTV cargo craft.
51、50、49、48、47、46、45、44、43、42、41、40、39、38、37、36、35、34、33、
T-minus 30 seconds and counting.
The launch deck water curtain starts.
28、27、26、25、24、23、22、21、
駆動用電池起動。
Thermal batteries activation.
15 seconds.
16、
フライトモードオン。
Flight mode on.
13、
10.
全システム準備完了。
All systems are ready.
9、
5 seconds to launch.
8、6、5、4、
メインエンジンスタート。
Main engine ignition.
Main engine start of the HTV. And liftoff. Liftoff of the Japanese HTV cargo craft heading for a rendezvous with the International Space Station next Thursday.
H2B ロケット2号機は平成23年1月22日
Pitch maneuver complete. The HTV now heading toward the southeast out over the Pacific Ocean.
宇宙センターから打ち上げられました。
We had a liftoff of the H2B launch vehicle number 2 with the Konotori 2 on board from the Tanegashima Space Center at 2:57 p.m. on January 22, 2011, Japan Standard Time.
打ち上げ以降、ロケットの管制は吉信発射管制塔から竹崎総合司令塔に引き継がれています。
After liftoff, the launch vehicle operation control was shifted from the blockhouse to the range control center.
ロケットは
50 seconds into the flight, the Japanese HTV and its H2B booster already going supersonic.
太平洋上へ飛行しています。
The HTV is now flying over the Pacific Ocean to the southeast with its initial flight angle of 108.5 degrees.
1 minute and 10 seconds into the flight, all systems performing well.
70 80
Coming up on the point when the 4 solid rocket boosters will burn out.
ロケットは正常に飛行中です。
The HTV is now flying smoothly.
110
SRBA 燃焼終了。
SLBA burnout.
120
JAXA confirming separation of the solid rocket boosters. These come off 2 at a time.
SRBA 第1ペア分離。SRBA 第2ペア分離。
The first and second pairs of the SLBA were jettisoned.
Both pairs of solid rocket boosters have now separated. One minute and 30 seconds from now, the fairing that protects and covers up the HTV at the very top of that rocket will jettison. And at that point, the rocket will be 75 miles in altitude.
The Ogasawara station has started tracking.
It's
3 minutes after liftoff.
第1エンジンの燃焼は正常。制御系、飛行経路も正常です。ロケットは順調に飛行を続けており、現在の高度は約 108km、秒速約 2.2km です。
The first stage engine combustion attitude control and flight trajectory are all normal. Current altitude is about 108 kilometers. The velocity is approximately 2.2 kilometers per second. Payload fairing jettison.
Confirmation that the fairing has been jettisoned. The first stage will continue to burn for 2 more minutes. There you see the smoke trail left there above the Tanegashima Space Center.
第1弾エンジンの燃焼は正常。制御系、飛行経路も正常です。
The first stage engine combustion attitude control and flight trajectory are all normal.
Here in Houston, the flight director, Jerry Jason, is about to wrap up his shift. He's updating the Expedition 26 crew on board the space station, talking with Katie Coleman there, informing her that tonight's launch was successful. The HTV continuing to head into orbit. The next milestone will occur at 5 minutes and 46 seconds into the flight. That is when the first stage engine will cut off.
ロケットは順調に飛行を続けており、現在の高度は約 160km、秒速約 4.3km です。
The flight goes very smoothly. Current altitude is about 160 kilometers. Velocity is approximately 4.63 kilometers per second.
A live view inside the control room at the Tsukuba Space Center. A team there continuing to monitor the progress of HTV as it climbs into orbit. We're standing by for the cutoff of the first stage engine, which is coming up momentarily.
第1段エンジン燃焼停止。
First stage engine cut off.
First stage engine cutoff confirmed.
第1段ロケット、第2段ロケットから分離。
First and second stages separation.
5 minutes and 54 seconds into the flight, the first and second stages have separated.
第2段エンジン燃焼開始。
Second stage engine ignition.
Confirmation that the second stage engine has fired. This will fire for more than 8 minutes. The second stage engine will fire until the 14-minute and 15-second mark.
The station has started tracking.
Live shots there from the Tsukuba space station. Mission control room. The Guam station has now started tracking.
制御系飛行経路も正常です。
The second stage engine combustion, attitude control, and flight trajectory are all normal.
Now more than 7 minutes into the flight, the second stage engine continues to perform as expected. The team there in Tsukuba, Japan is watching over all the systems on board. The Expedition 26 crew on board the space station is also following along. For the next 5 days, HTV will continue to perform a series of different orbital maneuvers as it closes in on the orbiting complex. Everything will be all set for Thursday's activities. That is when HTV will arrive within the vicinity of the International Space Station. It will perform a series of station-keeping maneuvers, and then ultimately it will get close enough so that the station's robotic arm under the control of Katie Coleman and also Paolo Nespoli can use that arm to reach out and grab onto HTV and to mount it to the bottom of the Harmony node.
第2段エンジンの燃焼は正常。制御系飛行経路も正常です。現在の高度は約 255km、高速約 5.6km です。
The second stage engine combustion, attitude control, and flight trajectory are all normal. Current altitude is approximately 255 kilometers. Velocity is about 5.6 kilometers per second.
The
flight goes very smoothly.
The flight controllers there in Tsukuba, Japan, continuing to give information on the performance of the HTV as it continues to head into space. It is now more than 160 miles high, continuing to gain velocity under the power of that second stage engine, which will continue to fire for another almost 5 minutes. We're now 9 minutes and 45 seconds into the flight.
It's 10 minutes after liftoff.
ロケットは順調に飛行しています。
You can see here
ロ
in
ケットは
the
種子島の
live
各地上
footage
局からの
of the mission
速範囲
control
を離
room
れ
here in Tsukuba, Japan.
小笠原
On the
局
right-hand side, he's moved
グ
out
アム
of
局から追尾され
behind
てい
that
ます。
pillar now, but he was
The flight
holding
is progressing smoothly. The launch vehicle is
stuffed
out of the
mascot
tracking range
of the
of the
Konotori.
Tanegashima ground stations, and the Ogasawara
Konotori now.
and Guam stations are tracking the launch vehicle.
flying smoothly.
第2弾エンジンの燃焼は正常。
This ground track and flight map being sent to us by the Japanese space agency JAXA. You can see HTV continuing to head to the southeast out over the parts of the Pacific Ocean.
約 6.4
We're now 11 minutes and 20 seconds into the flight.
Stage engine combustion, attitude control, and flight trajectory are all normal. The flight goes very smoothly. Current altitude is approximately 290 kilometers. Velocity is about 6.4 kilometers per second.
HTV is now 180 miles high. Flight Director Jerry Jason continuing to give updates to Katie Coleman, a member of Expedition 26, on the flight, but all systems are nominal. Everything is performing as expected. The next major milestone will occur in about 2 minutes and 15 seconds. That is when the second stage engine will cut off. And then a little less than a minute after that, at 15 minutes and 5 seconds into the flight, that is when HTV-2 will be separated from its rocket and will be in its preliminary orbit.
The 小笠原局がロケット追尾を終了しました。現在、グアム局から追尾を行っています。
The Ogasawara station finished tracking, and the Guam station is now tracking the launch vehicle.
The spacecraft currently being tracked by ground stations near Guam. But the smoke there above the Tanegashima Space Center is still very evident, even though we're more than 13 minutes past the launch time. In less than 1 minute, that second stage engine, which has been firing since the 6-minute mark, will be shut down. And then less than a minute after that, that is when the HTV cargo craft itself will separate from the rocket and will begin its solo flight.
The flight goes very smoothly.
Standing by for second stage shutdown.
Second stage
engine cut off.
The shutdown of the second stage engine has been confirmed.
ロケットは現在完成飛行を続けています。
The launch vehicle is in coast flight.
These are actual replays coming to us of when the SRBs were jettisoned. And there you see replay of the payload fairing separation. That was the cover that was over the top of the HTV itself. That took place at the 3-minute and 40-second mark. There's the first and second stage separation, which took place at 5 minutes and 54 seconds. And now back to the current view of the map itself.
HTV-2 separation.
HTV has separated from its rocket. It is now flying by itself. 15 minutes and 30 seconds after the liftoff. HTV now begins a 5-day trip up to the International Space Station, setting up for Thursday's rendezvous and berthing activities.
This is the end of the live launch report of the HTV launch vehicle Flight 2 with the Konotori 2 on board.
今後のコウノトリ2号機の状況につきましては、記者会見並びにプレスリリースにて発表いたします。種子島宇宙センター滝崎総合司令塔よりお伝えしました。ありがとうございました。
The flight status of the Konotori 2 will be announced at the press conferences as well as through the press releases. The live report of the HTV launch vehicle was from the Takesaki Range Control Center at the Tanegashima Space Center. Thank you very much.
So once again, a successful launch into orbit of the Japanese cargo craft HTV #2. This is the second time that this cargo craft has flown. The maiden flight was back in 2009, but a successful and by-the-book launch of this second HTV that is flying under the call sign of Konotori. That is the Japanese word for white stork. It lifted off from the Tanegashima Space Center at 11:37 p.m. Central Time. That was 2:37 p.m. on Saturday afternoon there locally.
Erfolgreicher Start. Japan hat ein Transportraumschiff auf den Weg zur internationalen Raumstation ISS gebracht. Die H-2B-Rakete mit dem Transporter hob planmäßig um 6:37 Uhr unserer Zeit ab vom Raumfahrtzentrum auf der südlichen Insel Tanegashima. Der Transporter bringt 6 Tonnen Lebensmittel, Kleidung und wissenschaftliche Ausrüstung zur ISS. Er soll am Donnerstag bei der Raumstation eintreffen.
Eine japanische Rakete ist am Morgen erfolgreich zur internationalen Raumstation gestartet. Der unbemannte Transporter hat fast 6 Tonnen Lebensmittel, Trinkwasser, Kleidung und technisches Gerät an Bord. Nach dem Andocken an die ISS wird der Transporter mit Müll gefüllt. Auf dem Weg zurück zur Erde wird er beim Eintritt in die Atmosphäre verglühen.
Es ist 18:45 Uhr, hier sind die Nachrichten bei RTL und das sind unsere Themen. Terror in Moskau. Bei einem Selbstmordanschlag auf dem internationalen Flughafen Domodedowo sterben mindestens 35 Menschen, mehr als 130 werden verletzt. Der Terror hat wieder zugeschlagen. Bei einem Selbstmordattentat auf dem größten Moskauer Flughafen Domodedowo sind heute Nachmittag mindestens 35 Menschen getötet und 130 verletzt worden. Die Explosion ereignete sich offenbar in der Nähe der Gepäckausgabe im internationalen Ankunftsbereich des Flughafens. Experten vermuten Terroristen aus dem Nordkaukasus hinter dem Anschlag. Burkhard Wennemer mit den ersten Bildern.
Der Ort des Anschlags unmittelbar nach der Detonation. Auf dem Handyvideo eines Passagiers ist dichter Rauch zu sehen. Überall auf dem Boden liegen verstreute Gepäckstücke, an anderen Orten auch Tote und Verletzte. Offenbar waren hier 2 Sprengsätze explodiert, gefüllt mit Metallstücken. 50 Krankenwagen rasten zum Flughafen und brachten die Verletzten in mindestens 4 Kliniken. Die Behörden stoppten sofort alle internationalen Flüge in Domodedowo. Auch Landungen von Maschinen aus Deutschland wurden zunächst nicht erlaubt. Russlands Präsident Medwedew ordnete im ganzen Land Alarmbereitschaft an und versprach, die Organisatoren des Anschlags zu fassen und zu bestrafen. Der Flughafen, 35 Kilometer südlich vom Moskauer Zentrum, ist der größte und beliebteste Flughafen der russischen Hauptstadt. Pro Jahr nutzen ihn rund 19 Millionen Fluggäste. Das rechte Terminal wird für Inlandsflüge genutzt, das linke für internationale Flüge. Dort passierte der Anschlag. Erst vor 10 Monaten hatten 2 tschetschenische Selbstmordattentäterinnen in der Moskauer U-Bahn 40 Menschen in den Tod gerissen. Es war der schwerste Anschlag seit Jahren. Tschetschenische Terroristen waren im Oktober 2002 auch für die Geiselnahme im Moskauer Dubrovka-Theater mit 170 Toten verantwortlich. Auch die Geiselnahme von Beslan 2004 ging auf das Konto von tschetschenischen Rebellen. Sie endete mit mehr als 330 Toten. Auch der jetzige Anschlag auf den Flughafen trägt nach Einschätzung von Experten die Handschrift von islamistischen Terroristen aus dem Nordkaukasus. Die Leiche eines Attentäters wurde mittlerweile gefunden. Die Polizei fahndet jetzt nach 3 Hintermännern.
Ja, und wir schalten zum Moskauer Flughafen Domodedowo zu meinem Kollegen Roman Schell. 4 Stunden ungefähr ist der Anschlag her. Wie stellt sich die Lage im Moment bei Ihnen vor Ort dar?
Draußen vor dem Flughafen ist alles mehr oder weniger ruhig, aber drinnen herrscht das Chaos. Es ist schwierig, da in das Gebäude reinzukommen. Vor dem Gebäude stehen große Schlangen von Passagieren. Sie werden streng kontrolliert. Das Gepäck wird sehr streng kontrolliert. Ich habe mit 2 Augenzeugen gesprochen, die auch momentan dort sind. Keiner hilft diesen Menschen. Und die Journalisten befragen sie natürlich die ganze Zeit, aber von Ärzten oder von Psychologen haben sie keine Hilfe bekommen. Wir können nicht sehen, wie die Leichen oder wie die Verletzten gerade transportiert werden, denn ein Teil des Flughafens ist völlig abgeriegelt.
Vielen Dank für diese Informationen. Roman Schell vom Flughafen Domodedowo in Moskau. Und über die neuesten Informationen zu diesem Anschlag halten wir Sie natürlich auch im Internet auf rtl.de auf dem Laufenden. Es ist 18:45 Uhr, hier sind die Nachrichten bei RTL und das sind unsere Themen. Tödlicher Terror. Unter den 35 Opfern von Moskau ist auch ein junger Mann aus Köln. Diese verletzte Deutsche schildert, wie sie den Anschlag überlebt hat. Unter den 35 Toten des Selbstmordanschlags auf dem Moskauer Flughafen Domodedowo ist auch ein Deutscher. Der 34-Jährige stammt aus Köln. Er war auf einer Geschäftsreise für seine deutsche Firma. Zudem zählt eine Frau aus Koblenz zu den rund 180 Verletzten. Russlands Staatspräsident Medvedev fordert nach dem Anschlag jetzt noch härtere Maßnahmen im Kampf gegen Terroristen. Burkhard Wennemar berichtet.
Ein im Internet aufgetauchtes Video zeigt den Moment der Explosion. Es stammt vermutlich aus einer Überwachungskamera. Sekunden später dreht ein Augenzeuge diese Bilder mit seinem Handy. Zum Zeitpunkt der Explosion hielten sich hunderte Passagiere und Mitarbeiter des Flughafens in der Ankunftshalle auf. Die Druckwelle der Bombe war so stark, dass viele Opfer bis zur Unkenntlichkeit entstellt wurden. Diana Stotz aus Koblenz wurde von herumfliegenden Teilen getroffen. Sie überlebte aber und liegt jetzt in einem Moskauer Krankenhaus.
Bei der Explosion war schon der Panik, ja. Die Leute haben sich versucht, irgendwo zu verstecken oder wegzulaufen. Dann hat versucht jemand, allen zu beruhigen, hat dann einfach geschrien, Ruhe, jetzt keine Panik, sonst kann es noch was Schlimmeres passieren, ja.
Auch der 34-jährige Hendrik Minderop aus Köln war in der Halle. Er wurde bei dem Anschlag getötet. Der Logistiker war für die Remscheider Weiland-Gruppe nach Moskau gereist.
Wir sind sehr tief bestürzt über den Tod unseres Kollegen Hendrik Minderop. Viele Kollegen hier in Remscheid haben ihn gekannt. Und ja, wir trauern alle von der Geschäftsführung bis zu den Kollegen und die Mitarbeiter. Wir sind alle sehr tief betroffen.
Noch immer ist nicht klar, ob der Anschlag auf das Konto eines Einzeltäters oder eines Pärchens geht. Ermittler fanden bislang den Kopf eines mutmaßlichen Täters. Den Angaben zufolge ist es ein Mann zwischen 30 und 35 Jahren mit südländischem Aussehen. Experten vermuten, dass der oder die Täter aus dem Nordkaukasus stammen, vermutlich aus Tschetschenien. Bei einem Besuch von Verletzten im Krankenhaus kündigte Ministerpräsident Putin harte Vergeltung an. Präsident Medvedev kritisierte scharf die zu laxen Sicherheitsbedingungen am Flughafen Domodedowo. Dort habe, so Medvedev, praktisch Anarchie geherrscht. Aus Trauer um die 35 Toten und 180 Verletzten legten Menschen Blumen am Flughafen nieder. Ansonsten hat der Airport seinen Betrieb wieder voll aufgenommen.
Ja, und dort vor dem Flughafen steht unser Reporter Rainer Munz. Rainer, Präsident Medvedev hat ja seine eigenen Sicherheitskräfte ungewöhnlich scharf kritisiert. Wieso ist er so aufgebracht?
Ja, das muss man schon sagen. Die Kontrollen im Eingangsbereich hier, die waren einfach lasch. Zwar gab es in dem betroffenen Bereich auch sogenannte Sicherheitsschlossen, aber die sind nie benutzt worden. Das haben mir meine russischen Kollegen heute mehrfach bestätigt. Das hat sich natürlich heute alles geändert. Wer jetzt rein will, der muss sein Gepäck durchleuchten lassen, muss selber durch eine Sicherheitsschleuse gehen. Aber wenn es dann piept, dann schaut die Miliz ziemlich gelangweilt weg. Genau das ist mir heute mehrfach passiert.
Russland vertritt seine Interessen im Kaukasus-Konflikt ja mit ziemlich harter Hand und es gibt Hinweise darauf, dass die Terroristen oder der Terrorist aus Tschetschenien kam. Gibt es überhaupt die Hoffnung auf eine friedliche Lösung, die dem Terrorismus von dort ein Ende bereiten könnte?
Da muss man leider sagen, es ist keine Lösung in Sicht, ganz im Gegenteil. Allein im vergangenen Jahr haben sich die islamistisch geprägten Gewalttaten im Nordkaukasus und in Tschetschenien vervierfacht. Russlands Antwort: sehr brutale Spezialeinsätze dort vor Ort und Die tschetschenischen Terroristen, die reagieren so darauf, dass sie die Gewalt immer wieder mitten hier in Moskau explodieren lassen. Das ist für die russische politische Führung auch deswegen so schwierig, weil 2014 die Olympischen Spiele hier im Lande sind, und zwar in Sotschi, also genau in der Pulverfassregion Kaukasus.
Vielen Dank für diese Einschätzung. Rainer Munz, live aus Moskau.
Die Regierung will Geld sparen. Bestellt werden sollen lediglich 40 Maschinen statt der zuletzt geplanten 53. Das gesamte Entwicklungsprogramm für den europäischen Transporter kostet mindestens 25 Milliarden Euro. Außerdem verzögert sich der Auslieferungstermin weiter. Frühestens in 2 Jahren ist mit einer ersten Basisversion zu rechnen.
Beginn der Weltraumexpedition nach Solingen-Ohlix. Frank Lungenstraß, Kommandant der Sternwarte, besucht heute zum ersten Mal seine zukünftige Heimatgalaxie. Mit seinen Fernrohren will er in dieser alten Gaskugel landen. Die Stadtwerke wollten den Druckbehälter schon mit der Abrissbirne ins Jenseits schicken. Jetzt gleich geht's für die Mannschaft durch die kleine Luke hinein.
Also mich erwartet wahrscheinlich ein großes schwarzes Loch da drinnen und ja, wahrscheinlich mit einem ziemlich heftigen Echo. Zumindest ist uns das so berichtet worden. Aber wenn man von draußen die Kugel sieht, 26 Meter, dann kommt sie einem ja groß vor. Aber ich glaube, von drinnen wird es noch gewaltiger sein. Ich bin mal gespannt.
Der Weg ins künftige Planetarium ist ein kleiner Kraftakt. Doch im Universum muss es ähnlich düster und kalt sein wie hier. 50 Jahre lang war nur Erdgas hier. Sternengucker Frank Lungenstraß ist beeindruckt. Optisch und akustisch. Im All ist Hall.
Auf der einen Seite diese gewaltigen Dimensionen, 26 Meter, das kann man sich von draußen gar nicht so vorstellen. Und zum anderen, wenn man sich dieses Industriedenkmal ja fast schon anschaut und sich vorstellt, dass man in dieses über 50 Jahre alte Objekt dann hier im Planetarium einbaut, ich glaube, das hätte sich nie jemand träumen lassen.
Das Innere der Kugel soll zur Projektionsfläche werden. Mit modernster Digitaltechnik könnten die Zuschauer wie in einem 360-Grad-Kino über ferne Planeten fliegen. Doch ganz einfach wird so ein Umbau nicht werden. Was machen Sie denn mit der Akustik hier?
Die Akustik wird noch ein großes Problem. Wir haben die Architekten alle darauf hingewiesen. Und ich denke, wenn hier ein paar Einbauten drin sind und die 12-Meter-Kuppel dann fürs Planetarium hier drin steht, dann wird man das wahrscheinlich so in den Griff bekommen.
Die Reise in den halligen Himmel der Gaskugel wollen die Stadtwerke finanziell mit unterstützen. Auch sie wissen, der bisherige Standort der Volkssternwarte ist für Vorträge oder Seminare viel zu klein.
Die Sternwarte ist auf uns zugekommen, hat uns von der Idee berichtet, hieraus ein Galileum zu machen, ein Planetarium. Und wir waren begeistert. Steckt in der Idee doch die Chance, den Gasbehälter, ein Industriegut sozusagen, zum Industriekulturgut zu machen und der Gesellschaft auch aus einer ganz anderen Perspektive nochmal neu zu zeigen.
Das Projekt soll nach 2 bereits gescheiterten Missionen zum Bau des Galileums jetzt den Durchbruch bringen, wobei die Kosten sprichwörtlich astronomisch sind.
Die Finanzierung ist schwierig, weil das dritte Projekt jetzt in diesem Falle auch das teuerste ist. Das muss man wirklich sagen. Wir reden von ca. 3,5 Millionen Euro Bau- und Umbaukosten plus dann nochmal eine gute Million für die erforderliche Technik. Es gibt durchaus positive Signale, einen erheblichen Teil davon beispielsweise aus öffentlichen Förderprogrammen bekommen zu können. Aber es bleibt immer noch ein großer Eigenanteil übrig und an den sind wir jetzt dran.
Mehr als 170 Architekten wollen die Gaskugel auf dem Weg ins All begleiten.
Spannendes Projekt.
Im Erdkern herrschen bis zu 5000 Grad. Er besteht aus einem Eisen-Nickel-Gemisch und ist trotzdem nicht magnetisch. Dennoch kann dort das Erdmagnetfeld entstehen, denn das Feld induziert sich durch die Strömungen im Innern der Erde. Die Erde besteht ähnlich einer Zwiebel aus mehreren Schichten. Erst kommen Erdkruste und Erdmantel. Dann ein Eisenkern, der so heiß ist wie die Oberfläche der Sonne und trotzdem fest. Dieser ist von einem flüssigen äußeren Kern umgeben. Zwischen dem heißen Kern und der kühleren Kruste entstehen sogenannte Konvektionsströmungen. Heißes Material steigt nach oben und kaltes sinkt nach unten. Ein Phänomen, das man bei kochendem Salatöl beobachten kann.
Diese Strömungen werden zusätzlich durch die Rotation des inneren Kerns in Bewegung gesetzt. Denn dieser dreht sich schneller als der Erdmantel. Es entstehen schraubenförmige Strömungsmuster. In dieser Strömung entstehen kleine magnetische Felder. Durch Streckung und Verwindung der magnetischen Feldlinien entstehen noch mehr Ströme und daraus wieder magnetische Felder, die die bereits vorhandenen verstärken. Durch die ständige Änderung und Bewegung des Magnetfelds strahlt die Erde elektromagnetische Strahlung ab, die das Erdmagnetfeld aufrechterhält und uns vor Sonnenwinden schützt. Trotzdem dringen noch Partikel durch den Schutzmantel der Erde. So entstehen die Polarlichter, die immer öfter auch weiter südlich zu sehen sind. Denn mit 40 Kilometern pro Jahr bewegen sich die magnetischen Pole von den geografischen weg. Das Erdmagnetfeld verschiebt sich. An Gesteinsstrukturen können Geophysiker ablesen, dass sich das Erdmagnetfeld in der 4,5 Milliarden Jahre alten Erdgeschichte schon viele hunderte Mal umgepolt hat. Das scheint es auch jetzt wieder zu tun. Es kehrt sich um. (2012) wird die Swarm-Mission der ESA das Erdmagnetfeld erforschen. Die Daten sollen Einblick in das Erdsystem bieten und das Verständnis um die dynamischen Prozesse im Erdkern verbessern.
Ist der Klimawandel deutlicher zu erkennen als am Schrumpfen der arktischen Eisdecke. Und das Eis schrumpft schnell, schneller sogar, als es der Weltklimarat voraussagt. Früher war das Eis im Schnitt rund 3,5 Meter dick, jetzt sind es häufig weniger als 2 Meter. Das Eis ist brüchig geworden. Wissenschaftler versuchen schon lange, die genauen Abläufe und auch die Ursachen dieser gigantischen Eisschmelze zu verstehen. Eine ganz neue Studie zeigt jetzt, dass in den vergangenen 2000 Jahren das atlantische Wasser in der östlichen Framstraße zwischen Grönland und Spitzbergen noch nie so warm war wie heute.
Wenn sich Forschungsschiffe wie die Polarsterne in die Arktis aufmachen, so kommen sie heute schneller voran als noch vor ein paar Jahrzehnten. Die Eisschicht ist dünn geworden. Robert Spielhagen und seine Kollegen erleichtert das allerdings nur bedingt die Arbeit. Zentnerschwere Bohrgestänge müssen in den Atlantikboden getrieben werden. Ihr Ziel sind Sedimentschichten aus Zeiten, in denen noch kein Mensch Luft- oder Wassertemperatur gemessen hat. Die Ablagerungen auf dem Meeresgrund sind ein Langzeit-Klimaarchiv, aus dem man nicht nur so einiges herauslesen, sondern auch schmecken kann.
Ich nehme eine Probe, eine kleine Messerspitze voll oder eine Zahnstocherspitze voll, stelle die Farbe fest, indem ich das mit einer Farbtafel vergleiche, und dann probiere ich das im Mund und stelle da so mit etwas Erfahrung zwischen den Zähnen fest, wie viel Sand da drin ist. Das ist aber eine grobe Beschreibung. Genauere Messungen machen wir dann nachher noch zu Hause im Labor.
Robert Spielhagens eigentliches Interesse gilt diesen Gesellen, arktische Foraminiferen. Fossile Einzeller, die sich im Sediment erhalten haben und aus denen man Wasser- und Lufttemperatur der Vergangenheit ableiten kann. 4 Jahre hat der Kieler Paläo-Ozeanograph mit seinem Team die Bohrkerne mit den verkalkten Tierchen ausgewertet. Die Methode war dabei einfach und effektiv.
Wir haben einerseits die Artenzusammensetzung untersucht. Da gibt es wärmeliebendere und kälteliebende Arten. Und je mehr von den wärmeliebenden in der Probe drin sind, umso höher ist die Temperatur, bei der sie in der Vergangenheit gelebt haben. Und über diese Artenverteilung können wir eine Temperatur der Vergangenheit rekonstruieren. Andererseits haben wir noch den Chemismus, die Magnesium-Calcium-Zusammensetzung in dem Kalk untersucht und auch daraus eine Temperatur bekommen. Die Ergebnisse beider Methoden stimmten sehr exakt überein.
Und es sind keine beruhigenden Ergebnisse. Das Forscherteam hat die Proben in der Framstraße zwischen Grönland und Spitzbergen genommen. Hier fließt der warme Golfstrom in den arktischen Ozean und sorgt auch im Winter für teilweise eisfreie Zonen. Der gelbe Punkt markiert die genaue Entnahmestelle der Probe. Mit dem Ergebnis?
Wir haben festgestellt, dass das warme Wasser, das in den arktischen Ozean einströmt, in den letzten 100 bis 120 Jahren und sich um ungefähr 2 Grad Celsius erwärmt hat. Und das ist eine Erwärmung, die es in den letzten 2000 Jahren in dieser Geschwindigkeit und in dieser Stärke niemals gegeben hat.
Mit Konsequenzen, die ein von vielen Wissenschaftlern angenommenes Szenario noch übertrifft. Die Eisschmelze wird demnach weiter zunehmen, denn das arktische Eis wird inzwischen von zwei Seiten angegriffen.
Die arktische Atmosphäre hat sich in den letzten 100 Jahren stark erwärmt, viel stärker, als sie es im Durchschnitt auf der Erde tut. Andererseits ist das warme Wasser, was in den arktischen Ozean einströmt, nach unseren Untersuchungen immer wärmer geworden. Und je wärmer dieses Wasser ist, was unter der kalten Oberflächenschicht drunter liegt, desto mehr wird einfach über normalen Wärmetransport nach oben transportiert und das verringert auch die Dicke der Eisdecke.
Und das fehlende Arktiseis verstärkt wiederum den Prozess des Klimawandels auf unserem Planeten, so die Annahme der Wissenschaftler am Geomar in Kiel. Denn wo die Reflexion der Sonnenstrahlen durch die helle Eisschicht fehlt, wird sich die Temperatur des dunkleren Ozeanwassers weiter erhöhen. Und am Ende wird all das kaum folgenlos bleiben.
Ja, es ist noch ziemlich unklar, wie solche Kipppunkte des Klimas das Gesamtsystem beeinflussen werden.
This is Mission Control Houston, and welcome to NASA TV's live coverage of the arrival of the Japanese HTV cargo craft to the International Space Station. This is a live view inside the flight control room for the International Space Station here at the Johnson Space Center. The flight director today is Ron Spencer. He will be overseeing operations from here inside the flight control room with his team. Sitting beside him is astronaut Megan MacArthur. She is serving as tonight's Capcom. This team here in Houston is working very closely with their colleagues at the JAXA Control Center, which is the Japan Aerospace Exploration Agency. That is in the city of Tsukuba, just outside of Japan. These two teams will work hand in hand over the next several hours as the HTV cargo craft nears the International Space Station complex and gets ready for this morning's grapple and berthing. And this is a live view on board the International Space Station. This is an over-the-shoulder camera looking at one of the TV screens there inside the cupola. That is attached to the Tranquility node. This is the robotics workstation that Scott Kelly, Katie Coleman, and Paulo Nespoli are currently working at as they monitor the arrival of this cargo craft. The sun is just beginning to rise as the space station and HTV fly in formation over the eastern United States, about to head out over the Atlantic Ocean. As you can see, this graphic overlay that the crew is monitoring as HTV continues to close in on the station. Right now it's about 30 meters away, which is a distance of about 98 feet. It is at a hold point right now for about the next 6.5 minutes. And once the go is given, that is when HTV will continue to close in to a point of about 10 meters or 33 feet. HTV launched last Friday evening from the Tanegashima Space Center there in southern Japan. It has spent the last several days heading toward the International Space Station, conducting a series of burns over this past weekend, as well as into this week. There was about 15 different engine burns that were conducted yesterday, as it continued to close in on the station complex. This morning's grapple is scheduled for 5:44 a.m. Central Time, 6:44 a.m. Eastern Time. And then berthing is due to take place around 8:15 a.m. Central Time. Well, that will take about 2 hours to accomplish. This is animation of the steps that HTV has gone through over the last couple of hours as it continued to approach the International Space Station from behind and underneath. While that was taking place, the crew on board the station was verifying that all the commands are ready to be sent from on board the station itself. The crew has the opportunity to send an abort command to the HTV should that be necessary. But if the clear is given, HTV will approach to within 10 meters, that's about 33 feet. And then Katie Coleman will use that robotics workstation to steer the station's 58-foot, 2-ton robotic arm out there to grab onto HTV, turn it around, and head it toward the bottom side of the Harmony node. There's a mechanism called a common berthing mechanism that is basically the hatchway and the attachment point that will bind HTV to the bottom side of Harmony. This is going to be a very slow step-by-step process as HTV gets berthed to that side of the International Space Station. At this point, Ron Spencer here inside Mission Control Houston is doing his final go, no-go for the HTV to depart this 30-meter hold point. As he's doing that, the crew is continuing to watch this onboard view as they take a look at the HTV as it continues to close in on the cameras and the station's robotic arm. That large box you see there, that is basically the target area that HTV needs to stay within. This is basically almost a step-by-step replay of what happened back in 2009, specifically on September the 17th, 2009, as the crew welcomed the very first HTV to the International Space Station. Nicole Stott, who was a member of Expedition 20 at that point in time, was the robotics operator. She is the one that actually grappled HTV for the very first time. This HTV is delivering to the International Space Station more than 4 tons of supplies, both pressurized and unpressurized. 51% of that is spare parts, 24% of that is food, 10% is science experiments, 8% crew supplies, and 7% is water. On the far right-hand side, that is the propulsion module of the HTV. That is where the engines and the fuel are stored. There's an avionics module that is right next to it. And then there's 2 major sections starting from the left. The far left is the pressurized portion of the HTV. That is the part that will actually be berthed with the station. There's a hatchway that the crew is going to be opening up on tomorrow, which that is due to take place at about 6:30 a.m. Central Time, 7:30 a.m. Eastern Time. And they will spend the next several days retrieving all the different cargo that is inside of that and storing it inside the station itself. There in the middle, you can see the unpressurized portion. There is an exposed pallet that is stored there that has 2 major portions of cargo that are stored on the outside of it. One of them is a flex hose rotary coupler that will eventually be stored on the outside of the station's structure. That is a part of the ammonia cooling system that circulates on the outside of the station's structure. That flex hose rotary coupler allows that ammonia to be transferred out to the large radiators as they circulate around the station's structure.
Is about half length aft with respect to the stroke tracker and about half diameter starboard with respect to the stroke tracker. Stroke tracker position, it's about it's very close to the crowbar corridor, slightly aft and slightly starboard.
We copy all. Thanks for the report, and stand by for the resumption from 30 meters.
Ron Spencer, the flight director here inside Mission Control, has just given the control center outside of Tsukuba, Japan, the go for final approach. Here in just a few minutes, the HTV will continue to close in to a distance of 10 meters, or 33 feet away from the International Space Station. That will be the final hold point. That is where HTV will stay until the station's robotic arm is used to reach out and grab onto it. Down below HTV is the Atlantic Ocean as the space station and this cargo craft fly together at an altitude of about 223 miles. You can also see a good shot of all the different solar panels around HTV. There's 57 in total. There's 20 panels on the upper part of the payload canister, the pressurized portion of that. There are 23 panels on the unpressurized portion. There are 8 solar panels on the avionics module and the propulsion module down there at the bottom where the engines are. There are 6 panels located there. While Katie Coleman has spent the last few hours getting the station's arm ready for this morning's operations, Paolo Nespoli has been working on a piece of equipment called the hardware command panel. This is sitting right beside Katie Coleman and Scott Kelly, where they are at the robotics workstation. This hardware command panel that Nespoli will be monitoring has several different buttons that can be used to either abort the approach of the HTV. It can force the HTV to be disengaged from the station's robotic arm.
Approach from 30 meters. You have a go to perform step 10 in procedure 1.102, and you are primed to issue retreat if nav range is less than 6 meters.
Copy step 10 in work, and we copy the commands.
Megan McCarthy there talking with Nespoli. On that hardware command panel, there's also a retreat button, which she was just giving him instructions on what to do if HTV closes within 6 meters, which would be a violation of the distance that HTV needs to maintain away from the International Space Station. If they push that command, HTV would back out to either a distance of 30 meters or 100 meters, depending on where they needed it to go. Once HTV gets to its hold point at 10 meters, or about 33 feet, they will put it in what is known as free drift. This is where it did not inadvertently fire. And this will put this cargo craft in the proper configuration for Coleman to use that station arm to reach out and latch onto it. All of those operations, once again, are due to begin around 8 or 8:15 a.m. Central Time later on this morning, and of course we'll have live coverage here on NASA TV of all of that.
Houston Station and 2 for corridor report.
Go ahead.
And Megan, first of all, I'd like to say that it's very difficult to actually visually see the strobe because during the day you cannot really see it. The position is Y strobe is within the crew aboard corridor limits. Vehicle size in both cameras matches the vehicle outline. The white strobe position is about half a diameter starboard of the strobe tracker, and the strobe tracker position is about slightly starboard and aft of the crew aboard corridor center.
And Paolo, can you confirm which camera you're calling that all that data from?
Actually, I was looking at both the camera 37 and 3.
Paolo, we copy. We're getting a status back.
Okay, Megan, I'd like to know if you're okay with our corridor report, or would you like another one?
And that's a good report, Paolo. We do not require another one. BVO is just running the numbers to ensure that you'll be within tolerance and the capture volume. Stand by for that feedback.
Copy, thank you.
Once again, this is an over-the-shoulder view of the onboard screen that the crew is monitoring as HTV continues to close into a point of about 10 meters or 33 feet away from the International Space Station. You can see that large box. That is where the HTV needs to stay within as it makes this final approach. If you look very closely, you can also see the outline on the screen there of the predict of where HTV should be. So Paolo Nespoli is calling down to the team here in Houston, letting them know the actual position of the HTV as it continues to close in to a distance of about 10 meters. Here inside Mission Control, the visiting vehicle officer who is sitting right beside right behind the flight director is continuing to give updates of the position of HTV. It's about 22 meters away at this point, which is about 72 feet.
Go ahead, Megan.
Paolo, we'd like to request that at approximately 15 meters, if you could make one more call down specific to each camera, the mast camera and the starboard lower outboard camera.
Copy, will go.
As part of the HTV's proximity operations system, there is what is called a Rendezvous Sensor, or RVS. This is a small sensor that is firing lasers at targets that are located on the outside of the Kibo laboratory. That is how the HTV knows how far away from the International Space Station it is. All of those are fed into a rack that is located inside the Kibo laboratory. And that gives the crew and the ground teams exact information of where HTV is located and its movement. During this part of its flight, the HTV's speed is anywhere between 1 meters to 10 meters per minute. So it's a fairly careful approach as it gets close to this huge international space station. Once it gets to about the 15-meter point, the crew is going to call down with another report of how things are lining up with what is expected of HTV versus where it actually is. Its final stopping point is going to be a distance of 10 meters or 33 feet. This is where it will be inside what is known as the capture box. This is where Katie Coleman will take over operations of the station's robotic arm to reach out and grab on to a grapple fixture on the outside of HTV. And then she will begin the process of maneuvering HTV around to line it up with the bottom side of the Harmony node. That is the ultimate destination for HTV later on this morning. That is the northern coast of Africa coming into view. The space station and HTV are flying at an altitude of about 220 miles now, heading down toward the southeast. The team here in Mission Control confirming that HTV has arrived at a distance of about 15 meters, which is 49 feet away from the International Space Station. The crew should be calling down here shortly with a report of what they're seeing on board.
Houston Station for a corridor report.
We're ready to copy.
So camera 37 MBS. The white strobe is within the global corridor limits. Vehicle size matches the vehicle outline. White strobe position is about a third of the diameter starboard of the strobe tracker, and strobe tracker position is about slightly aft of the global corridor center. How copy for 37?
We copy all for 37.
And camera 3, the white strobe is within the global corridor limit. Vehicle size matches the vehicle outline. White strobe is about a third of a diameter forward of the strobe tracker, and the strobe tracker position is slightly aft, slightly starboard of the global corridor center.
Paolo, we copy all. We appreciate the detailed call, and that is consistent with everything we're seeing, so we're happy. Thank you.
HTV and the International Space Station continuing to head over Africa. That is the Nile River there coming into view. These two spacecraft are going to be flying over parts of the Sudan, Ethiopia, and Somalia as they head out over the Indian Ocean. It's a fairly remarkable view here from the end of the station's robotic arm as HTV begins to rise from down below it. As we mentioned, the HTV is going to be holding at a distance of 10 meters, which is about 33 feet. This is the point at which Katie Coleman, one of the flight engineers for Expedition 26, will begin to fly that arm out toward the HTV, and will begin the process of grappling it. That will occur in the 8 a.m. Central Time hour, and of course we'll have live coverage of all of that here on NASA TV. HTV is bringing up more than 4 tons of supplies for the crew, both pressurized and unpressurized. This entire cargo craft is 33 feet long. It is 13 feet wide. 51% of that cargo is spare parts for the station. 24% is food for the crew. 10% is science experiments for the Expedition 26 crew to begin on board the orbiting complex. 8% is crew supplies, and 7% is water. This is a view from what is known as the centerline berthing camera. This will help the crew to make sure that HTV is properly aligned with that portion of the station. This is very similar to what we see during space shuttle missions during docking. So Katie Coleman will be the one that will be monitoring the condition of this common berthing mechanism as she makes sure that everything is lined up as expected. They're going to be communicating very frequently with the team here in Houston, and this team here on the ground in Houston is going to be working very closely with their counterparts at the Scuba Control Center just outside of Tokyo. This is a live view of that team, which had a big morning as HTV arrived at the International Space Station, and that attachment by the arm occurred at 5:41 a.m. Central Time. That control center erupted in cheers. That team there very happy after many, many months of working to make this mission possible. The Expedition 26 crew continuing to move the Japanese HTV cargo craft inch by inch toward the International Space Station. This is a very slow process. They will verify that everything is lined up according to plan. And the mission control team here in Houston is watching over their progress. This movement is so slow and so methodical, it's almost hard to tell that it actually is in the process of moving. But if you look at the very edge of the HTV there on the far left-hand side of your screen, you can see that it's getting a little bit closer to the International Space Station. Paulo Nespoli is driving the station's 58-foot-long, 2-ton robotic arm as he continues to drive this HTV toward the bottom side of Harmony.
And Houston, we got a bunch of pictures on SSC-8 whenever you want to grab them.
Copy that, Scott. We'll go get them. At station no response, we're doing the mail sync for you now.
Houston, confirm we have a go for step 5, maneuver to RTLs.
Katie, you go for step 5.
Good work.
This view gives you a good look at several of the different solar panels that are located on the outside of HTV which power it. There are 57 in total. There's 20 different solar panels on the pressurized portion, which in this view is at the bottom of your screen. There's 23 on the unpressurized portion, which is right there in the middle. There's 8 solar panels on the avionics module, which is near the top. And there's 6 panels up there at the very top, which is the propulsion module, which is where the engines and the fuel for the spacecraft are.
Houston, Station 2 Robotics.
Go ahead.
Do you guys see the CBCS view?
We do, Katie.
In the center, we see actually two red circles, and they're not concentric. Which one do we fly?
Yeah, we're seeing the same thing here, Katie, and we're talking about it.
Actually, no, they are concentric.
This is a view from the Common Berthing Mechanism camera on the International Space Station, looking down at the HTV as it continues to be steered into place by the station's robotic arm. The crew is verifying that everything is lining up according to plan. You can see HTV getting closer and closer to its final stop, which is the bottom side of the Harmony node. This cargo craft weighs more than 10 tons. It's got more than 4 tons of supplies on board. The arm itself weighs more than 2 tons. But they can both be moved inch by inch with extreme dexterity as they close in on one another.
Houston, we have 4 RTL, 7 centimeters.
Great job, and we see the same down here.
Neighborhood of the International Space Station currently closing at a rate of just under 12 meters per second. This is the view from the external black and white engineering camera on the Progress resupply vehicle as it looks at the International Space Station, beginning its final phase of its rendezvous for a docking to the Piers docking compartment, which was vacated last Sunday with the departure of the ISS Progress 40 spacecraft that was deorbited to a fiery reentry and its demise into the Pacific Ocean. The Progress 41 and its docking tonight will begin several months at the Piers docking compartment. The Progress is loaded with 3 tons of supplies for the Expedition 26 crew on board the International Space Station, including 1,918 pounds of propellant, 110 pounds of oxygen, 926 pounds of water, and 3,080 pounds of dry cargo, including spare parts and supplies for the crew. There are a number of notable cargoes aboard this Progress spacecraft, one of which is a small artificial satellite called Kedar. It is a 66-pound mini satellite that is designed to transmit 25 greeting messages in 15 different languages, Earth photos, and telemetry data for scientific equipment and service systems. It will transmit its signal at 145.9 megahertz with an amateur radio call sign of RS-1S. The satellite's name of Kedar is derived from the call sign for the Vostok 1, the spacecraft that launched Yuri Gagarin into space almost 50 years ago on April 12, 1961. Its purpose is to perform a space experiment called radioscoph, which involves the development and processing of a super small spacecraft during a spacewalk. This satellite will be deployed by Russian cosmonauts Dmitry Kondratyev and Oleg Skripochka during the next spacewalk they will take out of the Pirs docking compartment airlock on February 16th. The Progress is also carrying several books that were authored by the famous Russian space exploration founder Konstantin Tsiolkovsky, one of the founding fathers of spaceflight in the late 19th century and the early 20th century. Those books are sent into space to the International Space Station by his grandson, Sergei Samburov. In addition, the vehicle is carrying a surprise birthday gift for Station Commander Scott Kelly, marked not to be opened until February 21st, which will be Scott Kelly's 47th birthday on orbit. Ironically enough, the same day the countdown is scheduled to begin for the launch of Discovery to the International Space Station on the STS-133 mission.
The maneuver in progress. Copy, per page 20, you are go to issue Toro activation command. Copy and work.
The translation of the conversation between Russian flight controllers at the Russian Mission Control Center in Korolyov outside Moscow and Oleg Skripochka, who is at the controls of the Toru, or telerobotically operated rendezvous system, basically the manual backup rendezvous system in the Zvezda service module, which he would employ to manually fly in the Progress for its docking in the unlikely event that the Core's automated rendezvous system should experience a malfunction. The Core's was tested about an hour ago. Both the active system on the Progress 41 resupply vehicle and the passive system on the Russian segment of the International Space Station located on the Zvezda service module, all of the systems operating in good shape at this moment. We're about 8 minutes away from the Progress beginning its fly around of the International Space Station that will precisely align the Progress and its forward docking probe at a distance of about 160 meters away from the Pirs docking compartment docking port.
Forward to controllers is confirmed.
The International Space Station and the Progress resupply vehicle traveling at an altitude of 220 statute miles, moving from northwest to southeast in an orbit inclined 51.6 degrees to either side of the equator over the Pacific Ocean, due east of New Guinea at the moment, about soon to begin a southwest to northeasterly swing that will carry the two spacecraft towards its predicted docking point off of the east coast of South America. And there is a view from external cameras on the truss of the International Space Station, a good view of the Progress 41 craft, which now is just less than 2 kilometers away from the International Space Station, closing at a rate now of about 5.5 meters per second. And again, the view from the engineering camera on the outside of the Progress, looking at the International Space Station as it begins its final approach to arrive in the neighborhood of the orbital outpost. The 6 crew members on board the station, Commander Scott Kelly, the other USOS, or U.S. Orbital Segment crew members, NASA astronaut Katie Coleman, European Space Agency flight engineer Paolo Nespoli, and the 3 cosmonauts that are on board the craft, Alexander Kaleri, Dmitry Kondratyev, and Oleg Skripochka. The 6 crew members took about a 6-hour nap this afternoon to break up their crew day and to sleep shift them basically for the monitoring of tonight's docking operations.
Confirmed.
Once the docking has been accomplished and hooks and latches closed to form a hard mate between the two vehicles, there will be about an hour-and-a-half period of leak checks at the docking interface between the Progress and the Piers docking compartment before the hatches are scheduled to swing open just after midnight Central Time on Sunday morning, just after 1 a.m. Eastern Time. A very, very busy cargo pattern at the International Space Station, which is serving as a loading port, basically. The Japanese H-2 transport vehicle, the HTV-2, as it is known, the Kanatori, the Japanese word for white stork. It arrived at the International Space Station for a grapple and berthing on Thursday morning. That activity having been accomplished by Katie Coleman and Paolo Nespoli. The internal cargo already in the process of being transferred out of the HTV-2 into the International Space Station. Now it's the Russians' turn this evening with the arrival of the Progress resupply ship, and in just 2.5 weeks, the European Space Agency will be launching an Ariane 5 rocket through Arianespace. It's a launch firm and corporation from Kourou, French Guiana, carrying the Johannes Kepler ATV-2, the automated transfer vehicle, the second of its genre. It will be equipped with almost 8 tons of cargo to be offloaded to the International Space Station. And in the wake of the ATV-2's docking will be the arrival of the Space Shuttle Discovery and its 6 crew members led by Commander Steve Lindsay, who are scheduled, targeted at least for now, to launch to the International Space Station on February 24th. The Progress is in the process of conducting several small impulses or small burns from its thrusters to fine-tune its path to the station before moving into a fly-around of the International Space Station that will begin about 4 minutes from now. The Progress less than 1 kilometer away from the International Space Station, closing at a rate now of about 3 meters per second at the time of contact and capture at the Piers docking compartment docking port. The Progress will have slowed to a glacial rate of about 1/10 of a meter per second.
Copy. We have passed time T7. Do not see indication of course pair Sudan on the screen. Copy.
Here in the flight control room, the visiting vehicle officer, Tom Erkenswick, reporting to Flight Director Jerry Jason that the so-called Impulse 6 is underway. This is the final thruster firing before the fly-around of the station begins. You can see once again here that the Progress is aligning itself to begin the fly-around that will place it just 160 meters away from the Piers docking compartment for a short period of station keeping, while flight controllers at the Russian Mission Control Center in Korolyov outside Moscow have an opportunity to assess the alignment of the forward docking probe on the forward portion of the Progress 41 resupply vehicle with the Piers docking compartment.
Range 600, range rate 1.9, image is stable, we see the station in the sight. Copy.
And the visiting vehicle officer here in Mission Control tells Flight Director Jerry Jason that he is go for docking with the Corps' automated rendezvous system operating normally. The Progress is basically bouncing radio beacon signals back and forth to the passive system on the Russian segment of the International Space Station that updates the Progress's computers with its range to the Pirs docking compartment docking port and its rate of closure, which at the moment is 1.5 meters per second.
1.6. Copy.
You can see in this view of the Progress at the bottom of your screen that flashing apparatus is basically, that is the Corps' rendezvous system, the active system on the Progress resupply craft that again is sending a radio signal toward the passive system on the Zvezda service module of the Russian segment of the International Space Station to update the Progress's computers and to make sure it's on the proper alignment and the proper rate of closure for its docking that is scheduled at 8:39 p.m. Central Time this evening, about 25 minutes from now.
Range 400, range 1. Have visual confirmation. Copy. Heads up. 534 is eclipse. Parameters are on.
You can see the vehicle at the you can see the vehicle in the upper right-hand quadrant of this engineering view. That's the ISS Progress 39 spacecraft that is docked to the aft port of the Zvezda service module. It will undock in the next week and a half or so to clear that docking port for the arrival of the European Space Agency's Johannes Kepler automated transfer vehicle, which also docks to Zvezda. That's the only port that the ATV or automated transfer vehicle can dock to. The fly-around has begun. Progress currently making its way towards a precise alignment to the Pirs docking compartment.
Or will you do it from the ground? Okay, we will be utilizing presets. Range 330, range rate 0.75. Copy. C, displacement by 1. Stealth mark. Copy. Yes, Oleg, please report the matching configuration. Yes, of course. Range 300, range rate 0.65. Visually, SM diameter is within 1 cell of the overlay.
Progress now just 300 meters away from its destination, which is the Pirs docking compartment, closing at a rate of under 1 meter per second right now. This will set the Progress up for its station keeping point that it should arrive at in about 4 minutes for a period of about 7 minutes of station keeping, once again allowing Russian flight controllers at the Russian Mission Control Center outside of Moscow to assess the precise alignment of the forward docking probe on Progress with the Pirs docking compartment port.
Range 260, range rate 0.5. Visually, large diameter slightly exceeds 1 square on the overlay.
That's Oleg Skrypochka in the Zvezda service module, monitoring a variety of television monitors available to him as he assesses the alignment of the Progress's approach to the International Space Station for its period of station keeping.
Track range 240, range rate .26. We see the station, we see the service module. Visually, the large diameter slightly exceeds 1 overlay square. Copy.
The serenity of the South Pacific below the Progress 41 as it continues its fly around to position itself for a period of station keeping to align itself with the Piers docking compartment. The International Space Station and Progress traveling 220 statute miles above the Earth.
We see completion of fly around, rate 220, range rate .16. On the screen, I see the SM solar array. Copy. Large diameter measures 1 square and a quarter. Copy. I see roll maneuver. I see operation of the depot thrusters. Copy. Range 220, range rate .18. Copy.
The fly around of the International Space Station is complete. The Progress now in its roll maneuver that precisely aligns the docking probe on the forward end of the Progress with the Piers docking compartment and summarily aligns its solar arrays in the right angular configuration for approach and docking.
Visually, 1.5 image stable. Copy.
This will be just a few minutes worth of station keeping, once again allowing the Russian flight controllers to check out all of the systems. The Progress's approach is fully automated at this point in a pre-programmed fashion and has been since it reached orbit just 9 minutes after its launch on Thursday night U.S. time, early Friday morning Baikonur time from the launch site in Kazakhstan.
Is slightly less than 1.5 square of the overlay. Copy. Range 190, range rate near 0.
With station keeping in progress, it's notable to make aware once again of the remarkable international composition of what's going on at the International Space Station at the moment, with the Japanese H-2 transfer vehicle having been grappled and berthed to the Earth-facing port of the Harmony module just 2 days ago. Now the Russian Progress 41 craft closing in for its automated docking to the International Space Station, setting the stage a little over 2 weeks from now for the launch of the Europeans' Johannes Kepler automated transfer vehicle that is scheduled to be launched at 4:13 p.m. Central Time from Kourou, French Guiana on an Ariane 5 rocket for an 8-day transit to the International Space Station and its automated docking to the aft port of the Zvezda service module on February 23rd.
Large diameter 1.3 squares, Zavkon Prichal confirmation is on screen. Copy.
Once the final approach is reinitiated for a docking, you're looking just in the lower right-hand quadrant at the Pirs docking compartment port. At the very top of your screen at the aft end of the Zvezda service module is the ISS Progress 39 craft that will be undocked about a week or so from now. That will clear that port for the arrival of the Johannes Kepler automated transfer vehicle, the European Space Agency's cargo craft, on February 23rd.
Image still stable, continuing to see the station, large diameter 1.5 square, range 180, range rate is 0, Zavkon Prichal indication is on.
We're inside 4 minutes until the automatic computers on the Progress will initiate the final approach for docking. The Corps' automated rendezvous system will align the Progress so that when you see the view from the Progress's external engineering camera, the docking port should be right in the center of the engineering crosshairs that you see here. If everything is going as planned at a distance of around 40 meters, that Corps' rendezvous antenna will retract as planned, and then the telemetry will guide the Progress in the final few meters with docking scheduled at 8:39 p.m. Central Time, with the Progress traveling at a very, very slow rate of 1/10 of a meter per second.
Image is stable, continuing with the hold. Copy.
After docking, there will be a few minutes to enable the relative motion between the two vehicles at the docking interface to dampen out until it's very stable, at which point the forward docking probe will begin to retract. That will literally pull the station into the Progress to form a hard mate and enable hooks and latches to engage. That will be followed by about 90 minutes worth of leak checks at the docking interface between the International Space Station and the Progress to permit the opening of the hatches between the Progress and the Pirs docking compartment in the Russian segment of the International Space Station. Hatch opening scheduled just before 12:30 a.m. Central Time on Sunday morning.
Screen 44.4 still showing Zavkon Prichal, image stable, range 180, range rate near 0, large diameter slightly over 1.5 square of the overlay. Copy.
Ориентировочно в 5:28 начало причаливания.
128 is a reference point for start. Check that. 5:28 is expected start of final approach. Copy. We will be in eclipse at 5:04.
Once again, Russian flight controllers are reminding the cosmonauts on board the International Space Station, most notably Oleg Skripochka, who is at the controls of the Toru manual docking system in the Zvezda service module, should it become necessary to be used. That final approach is expected to begin less than 30 seconds from now. Everything has been flawless with the Progress has approached to the International Space Station. The core's automated rendezvous system is functioning perfectly.
See причал indication, TPO at thruster operation.
Alex Skripochka confirming that the command has been given on board. The Progress has initiated its final approach for docking. It now will close the final 170 meters, with docking scheduled about 10 minutes from now.
Range 160, large diameter, 1.5 squares, range rate, decimal 8. Причал, confirmation is on. Copy.
Excellent view of the thruster firings on the Progress from forward and aft jets on the resupply vehicle.
We have visual confirmation of all.
Now just 130 meters away, closing at a rate of 0.6 of a meter per second.
Range 110, range rate decimal 65, large diameter 2 squares, image is stable, docking assembly is in the middle of the screen. Copy.
The International Space Station and Progress have moved into an orbital sunset 220 miles above the Earth, beginning a southwest to northeast track, about to cross the west coast of South America over the Andes Mountains.
Image is stable. Copy. Range 90, range rate decimal 5. Copy.
Excellent view of the ISS Progress 41 resupply craft carrying 3 tons of supplies for the crew members on board the International Space Station.
Station Moscow, how copy? Station Moscow, how do you copy? Do you see the video? Yes, we continue to receive video, images stable. Docking assembly is within 1 square, range 66, range rate decimal 3. Copy. We do not receive the video on the ground, so please provide voice calls. Copy. Range 60, range rate decimal 25. Copy.
We're handing over between tracking and data relay satellites in the constellation of communications satellites. We should be regaining our television from the International Space Station and from the Progress relayed through the U.S. KU-band communications system momentarily.
2 minutes prior to eclipse. Copy. Range 50, range rate decimal 2. Docking assembly 1.5 squares.
This is the view from a balcony camera overlooking the cavernous flight control room at the Russian Mission Control Center in Korolyov outside Moscow. Progress now 50 meters away from docking, closing at a rate of 0.2 of a meter per second.
Range 50,
range rate, decimal 2, image is stable, pre-chow, confirmation is on screen.
Just a moment from now, the Corps' rendezvous antenna should be retracting.
Range 45, range rate, decimal 2, copy. We got the video back, but please continue with the voice calls. Copy. SSVP ready. Confirmation is on. TPO. Operation is confirmed. Copy.
Visiting Vehicle Officer Tom Erkenswick has reported to Flight Director Jerry Jason that the Corps' rendezvous antenna has retracted as planned, everything on track. Just 40 meters separating progress, and it's a port of call at the Piers docking compartment. You can see you're looking right down the barrel of the Piers docking compartment at the top of your screen. There is a docking target. You see that cross very near the where the crosshairs converge in this engineering overlay view. That docking target will be in the center of those crosshairs at the time of contact and capture.
We are in eclipse. Copy and confirm. Do you still see the target? We see the station, see the target.
In the lower left-hand portion of this view, you can see the two key numbers that the Russian flight controllers are monitoring. The distance, 36 meters, and at the very bottom, the rate of closure, or RDOT, as it is known in engineering terms, of 0.16 meters per second.
Range 30, range rate, decimal 15. Starting visual monitoring. Copy and concur. Причал still on, SSVP ready, on, assembly diameter just after.
25 meters separating progress and the Piers docking compartment, the International Space Station and progress, tracking from southwest to northeast up the east coast of South America, soon to pass just to the east of Buenos Aires.
Allo, removed. Confirmation received. Diameter 3 squares. Range rate decimal 13. We see a minor oscillation on the roll.
The minor oscillation reported by the flight control team in Korolyov should be self-corrected by the progress.
Range about 15 meters. Range rate decimal 12. Copy. See a small dispersion in the roll. Crosses are aligned. Image of the target is stable. Range rate decimal 12. Roll angle selected. Crosses aligned. I see the target.
The progress now inside 10 meters.
Range about 5 meters. Crosses are aligned. Target image is stable. Range rate decimal 11.
Nominal closure rate for the Progress now just 1/10 of a meter per second inside 5 meters. Standing by for contact and capture.
Copy. See small oscillation in the pitch. Past 3 meters. Copy. Crosses aligned, still continuing small oscillation.
Contact and capture, docking confirmed.
Copy. Mechanical capture confirmed. Copy.
Docking confirmed at 8:39 p.m. Central Time as the International Space Station and the Progress 41 resupply craft flew 220 miles just off the coast of Uruguay. For the second time in less than 3 days, an international cargo craft has weighed anchor at the International Space Station. The approach and docking flawless. Progress 41 now at the International Space Station. Docking occurring once again at 8:39 p.m. Central Time, 9:39 p.m. Eastern Time.